Good morning. Just continuing with the light lectures. So this one would be lecture light number 3, I believe. Today we're going to talk about the nature of light, continuing. And we're going to talk about light waves and frequencies, get a little bit more into the depth of our subject. So light waves and frequencies. Let's see. So lecture number 3, the nature of light, light waves and frequencies. I'm going to zoom in a little bit and then just continue. Let's start with drawing a wave. So I'm going to go ahead and first talk about light waves. So if I have a light wave, something similar to this. Okay, the distance from crest to crest would be the wavelength. That makes sense, doesn't it? So let me put a little marker right here. A little marker right here from crest to crest. That would be our wavelength. Now I'm going to use a symbol that denotes wavelengths. So from right there to right there is a wavelength, and the symbol is lambda. Okay, so this would be the crest. At the bottom of the crest is what we would call the trough. And a wavelength could also be measured from the bottom of a trough to another. So in this case, I'm going to use a in color to delineate the distance from right there to right there, from trough to trough, and that would also be lambda. So one wavelength. That makes that's pretty easy to do. Just the terminology. Just remember that lambda is a Greek word. Lambda. Okay, how do we define that? So let's talk about lambda. What is it? Is a wavelength basically the distance from a point on a wave to the corresponding point on an adjacent wave. To the corresponding point on an adjacent wave. To be able to look at this and how the waves work, just so you can play with it, there's a wave demo that you can go to. please navigate to the shortcut GOO.GL, the standard URL shortener for Google, /N, number 3, small r, small d, W, and M. And you can play with that and be able to figure out waves. Now, if we were to look at the electromagnetic spectrum, which we've discussed before, let's take a look at let's draw a line, and I want to make sure that you guys understand that it's drawn in books one way or the other, or on the net if you find them. I want to make sure you're familiar with no matter which way this is presented to you. So I'm going to go ahead and draw a electromagnetic wave, pretty long one, just so I can get all the naming done. So I'm going to start here and go to about 14 centimeters or so, and there. And every 2 centimeters, I'm going to make a mark, just arbitrary. Okay, so having done that, this is the EM. On the side, I'm just going to call it the electromagnetic spectrum. That's one presentation. And let me use a different color to label it. On the left, assuming this is the high energy side of this case, you would have gamma rays, then X-rays. You know what follows, we've done this enough. Ultraviolet, then visible light, infrared, normally abbreviated IR, microwave, and radio waves. Okay, so that should be pretty easy to be able to do that. However, again, I want to make sure that you understand that this can be presented in any way and we can interpret it just the same. So I'm going to go ahead and draw the same thing underneath it, same length even. So right here, all the way to 14 centimeters. And every 2 centimeters, just for convenience sake, more so than anything. Okay, now let's do the reverse in terms of naming this, because it can be presented either way, and I just want to make sure that you have it in your notes. It's familiar with either way, it doesn't matter. So if we put in this case the gamma rays on the right, then X-rays would follow, then UV, then visible light, then infrared, then microwaves, and then radio waves. Now, we understand that in the radio waves microwave area, there's TV, AM, FM, etc. We just combine it into one to make it simple. Now, I want to spend a few seconds here talking about visible light. But visible light, which we're very familiar with, this is when you end up getting into the familiarity that we learned perhaps in middle school or in physics. Roy G. Bibb. Remember those acronyms? They stand for red, orange, stand for red, orange, and I'm going to zoom in a little bit, see if I can get it to sharpen a bit, yellow, yellow, green, blue, indigo, and violet. So this right here, okay, is what our eyes can detect. What our eyes can detect. That's what our eyes can detect. Now, one comment on this is the wavelength of visible light is 740 nanometers through 300, approximately 80 nanometers. So you need to know this. Our traditional, keep an eye on that ojo. Okay, now I have to do a small pause for scale. I think I'm going to stop right there. Got about 10 minutes or so of lecture, and then take a break, and then we're going to go ahead and continue.